Good morning or good afternoon, depending on where you are. Hello, everyone. I'm Chris Spinagle from the Warning Decision Train Division. Along with me is Jessica Bunker, also from WDTD. I'd like to welcome you to today's Storm of the Month presentation. Today's presentation comes to you from the Warning Decision Train Division, and our presenter is Jim LaDue, who will be giving a presentation titled Calibrating the House DI, Guidance Tips on Dealing with the Slider Bar. With all that being said, Jim, the floor is yours, so go ahead and take it away.
Okay, thank you very much, Chris. I don't have much time here. I mean, I could spend literally a week talking about just the house DI because it's such a popular DI. And you can see this based on a study at NIST and their contractor ARA, Applied Research Associates, how many tornadoes have been rated using one of these DIs. And you just see the dominance of the house, especially when it comes to the stronger ones here in the orange and red values here. The house becomes critical. And so I wanted to share a little bit of that, of how do we handle calibrating the house DI, especially that slider bar, and removing a little bit of that uncertainty, about what to do with that slider bar. And the reason why is we've seen on the record, and the evidence is mounting, that we're seeing a reduction in numbers of strong and violent tornadoes at the expense of weaker ones. And we can see that through multiple lines of evidence. And so I think this gives us a chance and also a motivation to see about sharing information and doing what we can. And I'll spend what little time I have here to just walk through a few things that I've noticed. I also have a tool that ARA has been developing. It's still in development stage, but it's kind of like a great guidance tool. It produces probabilistic wind speed estimates based on the attributes of houses and then the building codes that they're in, year built, and et cetera. And, that could be a whole other thing that we can talk about. But I'll focus on a lot of these DIs, especially the ones in yellow, through some case studies and walk through a kind of a heuristic of what I'm looking at as we go forth. And yes, I do have an Oklahoma bias because this is where I do most of my damage surveys, but I do help a lot and provide guidance and consultation with the quick response team, especially from central regions. So there are some other cases too. But this one here, we start in the low end, and we have multiple shingles off this house. It's in East Norman, 26 February in 2023. And the key things are attributes. First is what year, or about when it was built, because that tells us a lot about what building codes that they were utilizing when constructing the house. And so this one here is typical 90-mile-an-hour code. We have a shingle roof, an L-shaped roof. I'm going to talk a lot about the shape of the footprint of the building. It also has gable ends, and that's something else I consider very strongly as well. But the gable ends, they survived in this case here. So what's the damage? We got loss of shingles, 20 to 30%, no roof deck damage. We have broken windows on the west side, but you can see the garage doors intact, and the gables are mostly intact except for debris impacts. So with that in mind, we focus on the shingles here. So we have two main types of shingles when we're talking about composite shingles. One is our what we call our contextual shingles, and the other one they're called 3-tab shingles. The architectural shingles looks like it closely matches with what we see here in terms of the pattern of the shingling. So, and they also underlap the next shingles above. The nailing pattern is right through the middle of the shingles, which is like directly underneath the next overlaying pair of shingles here on the upper side of the roof. So in that case, that has some weight and bearing as to how we slide the scale a little bit here. Is determining that 3-tab shingles are going out. If there are any left, they're probably quite old because the architectural shingles dominate the industry, at least at this point. So we do expect an expected wind speed with architectural shingles and a typical nailing pattern that we would see on most rooftops. If there are any 3-tab shingles left, they're weaker than expected. There is a but and a caveat with whatever shingles go up that we'll talk about. But at least for now, we'll cover these architectural shingles, the amount of damage here, and we'll apply DOD4 in this case, which is basically, actually, no, this one here is broken glass and doors, DOD3 to cover that. Now, I could use DOD4 to describe the damage to the roof as well, Okay, this one here is 96 miles an hour expected, and DOD 4 would be roughly about the same, 97 miles an hour. So there'd be very good agreement. And DOD 4, though, also encompasses garage door failures and also some roof deck damage or roof deck lifting. Now, a lot of times the roof deck can lift and then set back down. You wouldn't be able to tell from the outside, but you certainly would from the inside. So here's the caveat with any shingles, and that is the age of the shingles. So we have a great study here from the Insurance Business Institute for Home Safety. These are observations from Hurricane Ian in a report that Ian Giamanco, and Emily Newby, and William, I'm never going to pronounce his name right, Pogorzelski, I think is his name. But they looked at a huge survey of houses in Western Florida and noted their age, and then also using a wind speed analysis from NIST on the horizontal, you can see the amount of damage for each category. And you notice that the age is a huge factor, especially when it exceeds 12 to 14 years. Once you get up into the 15-year time frame, nearly inevitably, even for the lower wind speeds here, most of the houses have significant shingle damage. And so I think that's certainly true for any windstorm. They get enough numbers here to come up with some really good stats. And you can see the wind, of course, the percentage of shingle damage increases as the wind speed increases. The next thing here is that we want to go ahead and take a look. This is the slider bar that we have, where we have 63 mile per hour winds, lowest part of DOD 2, and then we go up to 97 miles per hour. DOD 2 is an example, but we could also use DOD 4 and use the same slider bar, just change the wind speeds. But here's where old shingles would go. 15 years or older, I would call them degraded enough that it would be 63 miles per hour, roughly the bottom edge of the slider bar for DOD 2, and correspondingly for DOD 4, also the same position on the slider bar. 3-tap shingles a little bit higher if they're relatively new, much younger than 15 years, for example. And architectural shingles roughly about the middle. I also added Spanish tiles, and where this picture lies relative to the slider bar is where I think the range of location would fall for that. Spanish tiles, as long as they're properly glued, with decent adhesive, would be a little bit above expected, and especially if they are mechanically fastened. So this is something that's common in Florida for either one. Standing seam metal roofs are pretty good as long as they're properly fastened as well, close to the top end of this slider bar here. And so this is something to think about, but they have to be properly sealed. Otherwise, they come off just as easily as shingles. Okay, so here's another story. So this one is, let's go again, a straddle between DOD 4 and 6, another roof deck story. And this one is the 15th of March, 2015 in Moore, Oklahoma. This one here, we had a 5,000 square foot frame house. The homeowner was he was the builder. So it was one of the people that the city council consulted with raising the building code in Moore to 130 miles an hour. So this house was built after that code, and everything was perfect except for one critical thing. And so we applied a DOD of large sections of roof structure removed, most walls remain standing, roughly somewhere below the expected because of this problem. And that is, if you look closely enough on the rafters here, we have a set of staples. And these staples were the only thing that were keeping the roof deck panels on the roof. So these are clearly below expected values, at least at this point here. So again, it's a subtlety that the building owner and the builder didn't realize until he looked at the roof together, and he looked at the staples and went, geez, that's where the roof failed. Because if you look down here on the rest of the roof, it's holding on just fine. So literally the deck panels are coming off, but not the rafters. They're not disengaging from the walls. So there we go ahead and say, yep, that's definitely lower than expected. I wouldn't worry about him though. He had plenty of resources available, including a second house where he stores his cars. So he was doing fine, but he did learn a lesson, and so did I on that day. So let's just stick with DOD4. This is something called a spectrum of roof, deck, and garage door resistance. And I haven't talked about garage doors yet, but this is something and a choice here that we can do that. DOD4 is up to, it's an uplift of roof deck, losses of significant roof covering material, collapse of chimney, garage door collapses, etc. And here I put staples somewhere in, down, maybe not all the way to the bottom, but down a significant ways from my expected value. A couple other things I put in here. Garage doors, standard garage doors will often fail at these wind speeds. And they'll result in, of course, all sorts of secondary damage that results from that as they add pressure to the interior of the house. So standard garage doors are less than 4 braces. The vast majority of garage doors are like this, even in new building and more, which was kind of surprising to me. Typically, if we want wind-rated garages, okay, they're going to be at the top of this scale here. They'll have multiple braces, in this case, 6, 7, maybe even 8. And they are quite different. The garage door tracks are also similarly reinforced. Okay, so that's the difference there at garage doors. With rooftops, rooftops often are, let's say the deck panels are adhered to the rafters with nails, typically 6D, which are 2-inch nails, or 8D, 2.5-inch nails. And so I laid these out correspondingly. This is also based on some of the modeling here. It doesn't produce a huge difference, by the way. We're talking about 10 miles an hour, but if you're on the fence between one rating and another, the difference between 6D and 8D might make the difference right there. Now, high end, like a fortified roof, the panels will be adhered either with some kind of adhesive as they waterproof the decking, okay, and or they'll add what are called, well, these are, they look like they're kind of look like screws, but they're called ring shank nails. And those things, the pull-out strength between a ring shank nail and a smooth nail, like over here, is huge. You cannot pull out a ring shank nail. Most often you're going to fail trying to do so. So total roof failure, when we get up to here, we have this case here back to 26 February 2023, and we have a greater than 3,000 square foot frame house. And this one was built around 2000, and it was done roughly to the 90 mile an hour code. Notice I say this one here is a complex roof and actually a complex footprint. And that also provides numerous opportunities for intersecting walls in the interior, as well as bracing within the roof itself to resist wind speeds from multiple directions. And so it actually has a significant impact on the performance of the house. Unfortunately, in this case here, the wind was strong enough to take off a large majority of the rooftop here, despite the fact that most of the roof was also a hip roof, except for 2 gable ends, which actually did survive just fine. So in this case here, we decided, well, we're going to go with the typical wind, roughly about there, straight up EF2. This is what we went to. This is the official rating that was supplied to this house, and it was actually not bad. This is a typical house, again, not clipped. We don't have anything extraordinary to keep this house and the roof together. But here's a different case. This, back to 26 Feb 23, this house is built in 2020 by a former Oklahoma Mesonet employee. And this one here almost has no visible damage from the aerial imagery, despite the fact that you see the trees had substantial damage, most of them being knocked down, and you can apply EF2 damage to those. The house was built to 130 mile an hour code. So what does that mean? It had numerous rafter clips, reinforced decking, adhesive insulation on the inside. The one area of damage that was significant to this house, and I don't have a picture of it, but the windows were broken. So this is what the interior that looks like inside the roof. And you see the decking with this adhesive style blown insulation in there, basically applied over the entire roof. And other parts actually had, the rafter clips and so forth attached to it. So as you notice here with the clips, they're attached to both the rafter and both top plates. That's a big difference right there. You got to get and engage the top plate right there in which the studs are connected, as well as the exterior sheathing. And the exterior sheathing is also structural. So it's not just that, that insulative sheathing. So those really attach and basically apply an above code appearance to that. Another example of above code, common in Florida, new building standards. This one built in 2006, post Andrew building code. And this one here exhibits DOD 4, right? Greater than 20% of the roof covering gone. But we have basically a minivan that's wedged into the front entrance of the building. And despite that, we also have a garage that did not cave in. So it was a wind-rated garage. And so you'd think, wow, okay, this is not an EF1. This is clearly at least EF2. And in fact, I could put this all the way up to the top, and I don't think it still justifies the damage to wind relationship here. And it could potentially even be EF3. Houses that were struck by tornadoes in Hurricane Milton exhibited the same behavior, by the way. So, but again, this is a high-end EF2, despite the appearance of it looking like it's just EF1 damage. So, with that said, if I look at the spectrum for DOD 6, from the low end, all right, is poorly nailed rafter to wall connections. As you can see, these things here barely go through the top plate and mostly missing the mark. And so if you get that kind of common behavior here, the roof is little more than just resting by gravity. Down below, this is actually a concrete wall house with these metal plates in which metal rafters were attached. But the metal plates had tiny screws that went in probably about a ½ an inch into the top of the concrete wall. There was no strapping or anything like that. That's no better than this at all. In fact, it's even worse than just toe nailing rafters to top plates. I also have the comparison here between gable and hip roof. Again, they're straddling both sides of expected, with a hip roof maybe slightly above, gable slightly below, and 10 to 15 miles per hour difference probably. But if you start clipping rafters together, or if you see evidence of these huge screws that go right from the top of the rafter down into the top plate, that's a big difference. Okay, let's talk about upper DODs. Now we'll talk about failure of walls and or slider, and what are the differences here. So for example, here, Clarksville, Tennessee, in late February of 2023, we got a 1,400 square foot frame house, straight nailed walls to floor, built around 1980 with a 90-mile-an-hour code, simple roof shape and gable ends. And you can see all walls down. In this case here, you see this wall back here, it's just lying on the other end of the pad. That wall only has single nails every 3 feet, basically going into this floor diaphragm here. So it's not actually the foundation. The floor is connected and bolted to the foundation, but it doesn't matter because the weak point is the 3-foot nailing pattern here above. So that caused, let's say, the entire wall system to fail because it doesn't take much to pull those out of the lower floor diaphragm. But there's an interesting thing. The official rating actually was a 2, and it was because the rater thought this was a slider. But I'm going to show you an argument why that's not a slider. So I was going to put this, all walls collapsed. Okay, that's a DOD 9 with lower end wind speed because of, let's say, the poor connectivity here. And so 143 miles an hour. So why isn't it this 120 mile an hour slider? Okay. And the reason is that it did not exhibit a rigid slide. In other words, the floor didn't go along with the rest of the house. And so the house disassembled piece by piece, and then the debris is left on the foundation and the floor diaphragm. If this had bolts and overlapping rigid sheathing, or at least even a few more nails for every stud here, it would have been an EF4. Okay, now what's a slider? This is a classic slider. This is from Greensburg, Kansas in 2007. And you can see that the majority of the house is intact, minus the roof. It slid off of the foundation. There's no floor diaphragm here or anything like that. It just went floor and all. And so that is what we talk about as a slider. And yes, that would be an EF2. That's what this one was rated. Now, if we go up to failure of walls, and this is in a second case here, DOD 10. Okay, in this case here, this one was up in Elk Ridge, Nebraska from April 26th of 2024. And this one here, initially, they went all walls collapsed. You could also very easily say it was more than that because the foundation was swept clean. So why didn't we go totally EF5? By the way, these are not small houses. These were rather large, 2,500 square foot houses built in 2023. So unfortunately, the residents only got to enjoy their house for less than a year before this happened. But fortunately, nobody was seriously injured or anything like that. They were actually out of the house. But in this case, the surveyor up there said primary connector floor to walls were nails, and the silt plate was bolted. Actually, it was more than that. Is the floor diaphragm here. This whole floor diaphragm was bolted to the foundation. So you see the diaphragm of the floor, and then we got the silt plate. That all of that was bolted down to the foundation. But the walls that were here were basically straight nailed in. So they decided, hey, we're going to go with 167 miles per hour. So lower end EF4. I could have easily have gone higher than that because of the amount of debris that was swept for the distance it was swept by. It was substantial. If I had EF5, I would have needed some overlapping wall sheathing onto the bottom floor, or at least toenail studs to the floor, or something a little bit more than just pure straight nailing. This is based on the modeling study as well, looking at both of these options right here. So unfortunately, northern housing and floor diaphragms, and also in the southeast US, the floor diaphragms and the walls are just connected by straight nails for the large majority of those houses. So with this one here, I went with, looking at DOD 7 through 9, or 10 actually, no, 9. Shot pins, that's weaker than expected. Bolts with nuts and standard washers, that's roughly expected. If I have rigid sheathing covering both the sill plate and nailed into it, and then going all the way up to the top plates where the rafters are connected, okay, that one I would be going with above expected. And then if I have double strapping, okay, double wrap strapping, both roof to wall and wall to foundation, okay, where we got bolts, then that is high end. In fact, that might even be a little bit off the top of this scale. And if I just have single straight pins, nails like this, and that's it, every 3 feet, it's just not quite there. So that's definitely below expected too. EF5, what are we doing more? We did sill plates bolted to nuts and washers, and the walls were toenailed down. And that was the key thing. The bolts are actually bent, so it took a lot to actually bend those. And that was the key. That was the key difference. But those houses probably only had corner sheathing, not full wall sheathing, like you'd expect with 130 mile an hour codes. So it's not like we're expecting a total fortress, but just looking for a little bit more than what I've seen so many houses out there exhibit. So that's my spectrum there. And you can see, again, very similar arrangement as well is what we have. This is the key thing, though. You're straddling that 200-mile-an-hour barrier. Makes the rating system very difficult. So what I'm going to do is just to make the main points. Hopefully this helps a little bit. Remember, the complexity of the house footprint really helps. Most homes are weakly constructed, but the scales are calibrated mostly to those kinds of construction levels. So you don't want to go overly conservative on things. So go with expected wind speed unless you're unsure. All right. But still, having said that, it's still difficult to get a 5 out of a 4. And there's some resource items right there. So that's all I got to say. And I'd be happy to take any questions.
All right. I want to thank Jim for taking the time to do the presentation, as well as to all of you for taking time out of your day to attend. Otherwise, thanks again for your time and enjoy the rest of your day. Thanks, everyone.